Hi, so today we're going to be talking about applying trigonometry, and that means we're going to be looking at word problems, how we can use that trig that we've been learning in class. So a couple things, really important that you draw a proper drawing. But remember, if it's trigonometry, we're going to be trying to get to a right triangle. We're trying to get to a right triangle. Now, to understand a lot of these drawings, a lot of these examples are going to involve something called an angle of elevation and depression. And an angle of elevation goes from a horizontal line. It goes from a horizontal line up, from the horizontal up, and an angle of depression is going to go from the horizontal line down. I mean, think about elevating your leg. You're laying on the couch. Your doctor had told you because you hurt your knee to elevate your leg. So there's your leg on the couch. If you elevated your leg, it would look like it'd be raised up like that. That's the angle of elevation. Same thing with depression. If I have a horizontal and it's an angle of depression, it's going to be going down, and there's the angle of depression. Okay, so let me show you two examples. A kite is flying at an angle of elevation of 40 degrees. So here I have a kite, okay? It's flying in the wind, right? And it's flying at an elevation. So you're here. It's flying at an elevation of 40 degrees. So I'm going to create my horizontal. The angle of elevation would be up to the kite, and so this would be 40 degrees, okay? All right, the Goodyear blimp hovers over a baseball stadium. So here's the blimp, okay? It hovers over a baseball stadium. I'm going to actually draw a big blimp. And here's the baseball stadium. I'll call that S. At an altitude of 125 meters. So that means that that blimp above that stadium is 125 meters perpendicularly above the ground, okay? Because it says the word altitude, and we know altitudes are perpendicular. The pilot, so up here, here's his eyes, he sights a tennis court over here at an angle of depression of 8 degrees. Now, depression, you got to be really careful, because if I go down like this, I want to make sure you understand, okay? That's where he's looking. This is not 8 degrees. The angle in the triangle is not 8 degrees. The angle of depression is. So remember, that means from a horizontal line going down. So that's 8 degrees. So how am I going to get that 8 degrees into my triangle? Well, if this is parallel and if this is perpendicular and this is perpendicular, these have become these horizontal lines that are parallel, which means these angles are alternate interior angles and are congruent. All right, so we're going to put this all into practice to solve a trig problem, okay? A problem involving trig. Okay, so here we have a tree, and it casts a shadow 21 meters long. Now, shadows, make sure you understand, shadows are on the ground. So here's my tree, okay? It casts a shadow 21 meters long. We've done some like this already. So there's my 21. The angle of elevation to the tree is 51 degrees. So the angle of elevation to the tree would be from this horizontal going up, so that's 51 degrees. What is the height of the tree? Okay, so this is a picture of what we're doing. And again, drawing an accurate picture takes practice. All right, so now I look at it and I have a reference angle of 51. In reference to that angle, I want the opposite. I have the adjacent, so opposite and adjacent is TOA. So then we write our equation. Remember, it's tangent. So tan of the angle, 51 degrees, equals the ratio of the opposite over the hypotenuse. Okay, now we solve. To solve this equation, we are going to multiply. We're going to clear fractions, multiply both sides by 21. So we get 21 tan 51 equals h. Okay, so that's calculator ready. Now we grab that calculator. We plug in 21 tan 51. And we get a height of 25.9. Now, we want to make sure that we were in the right mode, right? If we didn't get 25.9, you better check that mode and make sure you're not in radian mode. We always want to be on these in degree mode. Okay, let's try another one. A 15-meter pole is leaning against a wall, okay? So when I say a pole is leaning against a wall, so here's my wall, okay? The pole's leaning against it, so it's like that. There's that pole, and it's 15 meters. The foot of the pole is 10 meters from the wall, okay? So that means that this distance from here, that's the foot of the pole, to the wall is 10. find the angle the pole makes with the ground. So here's the pole, and here's this 10 is the ground. So I'm looking for the angle the pole makes with the ground. I'm looking for this angle. I'm going to call it angle X, okay? I look at what I have now. I have a right triangle. Again, we're trying to draw a right triangle. And so I look at that as the reference angle. What do I have? What do I need? Okay, well, I'm looking for an angle. So let's see what I have. I have the adjacent side to that angle and the hypotenuse. I have adjacent and hypotenuse. So A and H would be cosine, right? So katoa. So katoa. So I'm going to use cosine. So again, our equation would be cosine of the angle. So cosine of X equals 10 over 15. Now, ratios, because they're ratios, we can simplify them, and they'll give us the same result. So that gives me 2/3. So I'm going to look at that. Now, I'm trying to find the angle. Okay, we're trying to find the angle. So if we're trying to find the angle, if we need the angle, we need to use the inverse. Remember, this is where we use now. We need the angle. We have to use the inverse function. So on our calculator, we press second cosine, and what will appear is cosine inverse, so the inverse cosine. Remember, that's not the -1 power. It means the inverse cosine, parentheses, and you'll plug in 2/3. And that's saying, okay, I want the angle. All right, so let's try that. Second cosine, 2 divided by 3. So it gives me approximately 48 degrees. Okay, so it makes a degree measure of about 48 degrees. All right, one more. Let's try one more. Okay, just one more. All right, so this one's a little bit tough. The angle of depression from the top of a tower to a boulder on the ground is 38 degrees. So here I have a tower. Okay, there's my tower. I know some of you are going to want to draw those pictures really pretty. Okay, and here's a boulder on the ground. Okay, there's my tiny little boulder. The angle of depression from the top of the tower, so up here, to the boulder is 38 degrees. Okay, so I'm going to draw a line to the boulder. That's the line, but that's not the angle of depression. Angle of depression goes from a horizontal down. So the angle of depression is 38 degrees. It says that if the tower is 25 meters high, how far from the base of the tower is the boulder? So I'm looking for the distance from the base of the tower to the boulder. So I'm looking for X. All right, so I have a right triangle because the tower and the ground create a right angle, but I need an angle in here. And so remember these angles, the angle of depression is equal to the angle of elevation right here because they're alternate interior angles. Once again, now I'm ready to solve for X. 38 is my reference angle. In reference to 38, I have the opposite. I want the adjacent. Opposite and adjacent is TOA, so tangent. So again, we write our equation. Tan of the angle, so of 38, equals 25 over X. All right, so this one's one of the more complicated solving. Again, we follow the same rules. We clear fractions. We multiply both sides by X. So we get X tan 38 equals 25. Now, remember that function, that tan 38 is being multiplied to X, so I'm going to divide it on both sides. Tan 38. So now these simplify to 1, and I get X equals. So I'm going to grab that calculator. I'm going to do 25 divided by tan 38, and I get approximately 31.998. So we'll say 32. So the boulder is about 32, was it meters? 32 meters from the tower. All right, guys, so if any of that was tricky, I want you to rewatch. If not, you can go on to the 8.7 practice, and whatever you don't finish is going to be homework for you over the weekend. Have a great day.